Recording. All right, guys, we're going to look at logic terms. So I want you to put this in your notebook. It's the 5th of October. We're going to call this logic terms. Okay. All right, the first vocab word we're going to look at is inductive reasoning. Inductive reasoning is drawing a conclusion from a pattern or a series of examples. Drawing a conclusion from a pattern or a series of examples. So one of the ones I like to use, and I'll make this bigger so you guys can actually see it, is if we have like a set of x and y's, right? And we said we have got 1, 2, 3, 4 on our x, and our y's are for 1 it's 3, for 2 it's 3, for 3 it's 3. What do you guys think it's going to be for 4? Based on this set of numbers, what do you think 4 is going to be? 4, right? Because it's 3, because it is a pattern. So inductive reasoning is logic based on a pattern. Okay, now we've got deductive reasoning. Deductive reasoning is drawing a conclusion from a known fact or set of known facts. So the example I like is basic algebra. 2x equals 4, so you divide both sides by 2, and we get x equals 2. We used algebra in order to do it. It's known fact. Everybody have at least inductive reasoning so I can move it up? Okay. A conditional statement is a statement that has a condition in it and then a result that happens when the condition is met. A conditional statement that I often like to use is like, if it's a Tuesday, then it is a weekday, right? It gives you, it must be something because. Okay, moving up deductive reasoning, so hopefully you'll have that. I'll keep conditional up there. And we're going to move to if-then. A conditional statement written in an if-then format. That's almost always how we do conditional statements in mathematics, is an if-then. Okay. Hypothesis. What's a hypothesis in like a science class, guys? It's like an educated guess or a prediction. A hypothesis in math is the if part of an if-then statement. sometimes called an antecedent. I can't pronounce that word. Antecedent? There you go. Which you'll probably only hear again if you take like super upper level logic classes. Nope, 2 more. Am I going too fast or is this good, guys? Slow down a teeny bit. Okay, I'm going to move up the if-then a little bit, all right? Conclusion is the then part of an if-then statement, sometimes called the consequent. You can think of it as like a consequence. Consequent. So like one I like to use is if you're caught staying out after curfew, then you get grounded. Notice I said if you're caught. But you should all never break it. Oh. Mr. Bergman had a good one. He said something like, if you're texting a girl that's not your girlfriend, then you should stop or suffer the consequences. Okay. Ready? Moving up hypothesis, conclusion will still stay up there. Law of detachment. So the things I underlined with red were just me being funny. They're not. You don't need to write them down. Law of detachment seems silly, but it's very important. If the hypothesis of the if part of an if-then statement is true, then the then part must be true. Always, always, twice on Tuesdays. So you can only use law of detachment if it works. If it's true. All right, do we got this all down? Or we need a few more minutes? A few more seconds? Okay. We're going to move to your Venn diagram worksheet. Venn diagram worksheet. Okay. In the Agatha Christie's Murder on the Orient Express, they made this into a movie too. A murder has occurred. One scenario is that the conductor who left the train because the train is stuck in a snowbank is the murderer. The detective is logically trying to solve the murder. He uses a crushed watch to determine the time of death. Therefore, the detective says, if the crime was committed at 1:15, then the murderer could not have left the train. The detective's statement is an example of a conditional statement, where the if part is the hypothesis and the then part is the conclusion. A conditional statement can be represented symbolically by A to B, reading if A, then B. In the Murder on the Orient Express, A represents the words, a crime was committed at 1:15, and B represents the words, the murderer could not have left the train. The situation can also be modeled using a Venn diagram, where the inner circle represents the A part of the conditional statement, and the outer circle represents the B part of the conditional statement. So, we look at it right here. This is wrong on your paper. This should be A in the middle. B is on the outside. A, the crime was committed at 1:15. B, the murderer could not have left the train. Okay, so this is just a little bit of a different, instead of like interlocking chains like you usually think of, like we usually think of Venn diagrams look like this. This is just a different kind of Venn diagram. Okay? So we're going to go, oh, you can't see it. There. Let me zoom out a little bit. Okay. So we're going to make another Venn diagram for number 1 together, and then the back you guys are going to do for homework, okay? If a flag is the current United States flag, then it has 50 stars on it. What is the hypothesis of this? What's the hypothesis of this statement? A flag is the current flag. We'll just put U.S. U.S. flag. Okay, so that hypothesis goes in the middle. What is the conclusion of the conditional statement? It has 50 stars on it. Okay, so we're just talking about hypothesis and conclusions. Go ahead, you can do the back now on your own for the rest of class. And it will be homework. I will check it in on Monday, or Mr. Bergman will.